Welcome back. In the previous video, we saw that blocking functions, like our delay, could cause our entire server to massively slow down. Our delay function isn't very realistic. We could replace it with a non-blocking call to set timeout, for example. What are some examples of real-life functions that act like our delay function, blocking the event loop? Two functions that you're very likely to see are the json.stringify and json.parse functions, where json.stringify takes in a JavaScript object and returns the string representation of that, and json.parse does the opposite, where it takes a stringified object and returns the corresponding object, while stringify returns the string representation. And let me comment these out. Now, with typical objects, these functions don't quite take 9 whole seconds to complete. They'll finish in just a few milliseconds, even for large JavaScript objects. However, if you have a server that takes in many requests, this can add up, especially if every single request is making a call to json.stringify, which is common, for example, when logging objects. If calling this function blocks your server for 10 milliseconds, and the rest of your request takes 10 milliseconds, you've now doubled the time your server is responding to that request. But more importantly, that's 10 milliseconds that your server can't respond to any other requests. A second request that comes in won't even be able to start before your blocking json.stringify call returns. This can quickly spiral out of control. Now, some other common functions to watch out for are sorting arrays. For example, using the array.sort function. Say we have an array of 5 numbers. If we call .sort, we're now blocking the event loop while these numbers are sorted. For very large arrays, or for very large objects, these functions can start to get very slow. We also have certain functions in Node's built-in crypto module, which has functions related to cryptography and security, which are designed to execute slowly, so that it takes longer for hackers to guess your password. For example, we have the crypto.pbkdf2 function, as well as the crypto.scrypt function. These are both what's known as key derivation functions, which we use to create hashes of users' passwords, so that our servers don't need to actually store the user's passwords in plain text, but instead as this hash, which usually looks like a series of random letters and numbers. We want it to be expensive and time-consuming to use these hash functions so that hackers can't check tens of thousands or even millions of passwords per second, but instead, they need to dedicate a significant chunk of their computing power, even for one password. When it comes to security, we have this funny reversal where slow blocking functions are sometimes what's actually desired and are better than having quick, easy-to-compute functions. What we're doing with the delay function is simulating the extreme worst case of this blocking behavior by having a function that completely blocks the event loop for many seconds. 9 seconds is like 9 years when it comes to response time. Typically, for real-life applications, you want to keep your response times below 100 or 200 milliseconds at most. There have been studies that show how response times are perceived by humans when it comes to the web and applications. And it's been shown, going back to even 1968, that about 100 milliseconds is the limit for you and I to perceive something as reacting instantaneously. That's what we want. And any longer than 1 second, and it's likely that the user's flow of thoughts might be interrupted. You may start losing context on what you were trying to do. Any increases beyond about a second are likely to show a progressive decline in the amount of users who stay engaged with your website. If I scroll down on this article, we have an example where load times longer than 3 seconds resulted in 73% of users losing interest. Now, of course, it depends on what your site is doing. So if the user expects a large file or video to be loaded, they might be a little bit more patient than if they are expecting real-time stock and investment information. But for sure, if I click submit and nothing happens for 9 seconds, I'd leave the site for sure. Spinners and loading indicators can help, but after a point, they can become annoying. If you're running an online store, for example, you can use this information about how many users leave your site based on response time to calculate how much revenue each added millisecond loses your store. You can take the average amount of money that your users spend on your site in your store and multiply that by the amount of users that become disinterested when the loading time is past a certain point. These are just a few examples. Needless to say, there are strong arguments for having performance servers and low response times. Now that we know what functions to look out for, and we know why having low response times is important even if our event loop is blocked, let's find out what we can do to improve the situation. We have some good options, so I'll see you in the next one.